Hey y'all, welcome back to my channel. My name's Sarah from Life with Miss H, and I am a middle school teacher from Kentucky. And I'm glad that you were able to join us today. Today we are going to look at factors. We're going to talk about factors, how you find them, and how you can use them to find greatest common factor, and also to factor an addition expression. So let's get started. Remember, I do make a mistake in this video for my students to identify as extra credit. If you want access to this document that I use in this video, feel free to email me. My email is in the description link below. I'm happy to share them with you so students can work through the examples together, parents can work through the examples with their kids, and also teachers can use it in their classrooms. Factors. And you can also follow me on Instagram just to see what videos are coming up. And also you can ask or recommend some videos that you would like help with. Factors, they are numbers we can multiply together to get another number. And when finding factors of a number, try to think of all the numbers you can multiply to get that number. In this case, knowing those divisibility rules would help tremendously. Look forward to a video on that coming up. I love referencing the divisibility rules in my classroom. Some methods of finding factors are a factor rainbow and a factor T-chart. My personal favorite is the factor T-chart because it is so useful when you start answering word problems and also factoring those addition expressions. You can use factors to find the GCF of a number using those factors. The GCF stands for greatest common factor. The GCF is the greatest number that is a common factor of two or more given numbers. So you can find the greatest common factor of two numbers, three numbers, however many the question asks for. You can also use the greatest common factor to factor an addition expression to represent it as a distributive property. So before we start looking at examples, we're going to try something new that I'm going to try to do in all of my videos. We're going to use this work mat that we're going to start with the concrete, and we're going to use manipulatives, and then we're going to look at semi-concrete, which we will draw the models, and then we're going to do abstract, and that's using those different methods. In this case, it is the factor rainbow or the factor T-chart. So today we're going to use these little unit cubes, and I just want to start talking about how we can find factors of 12. So I have 12 unit cubes here, and we're going to find models of how we can form 12. The first number that I can think of is 1. So we are going to line up all of these little cubes. So this means we have formed a 1 by, and then you can count the cubes, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whoops, too many, 12 cubes. So I know two factors of 12 are 1 and 12. So let's go to 2. So I'm going to have a pair, and I'm going to line them up by 2s to see if we get a pretty number. So we don't have any oddballs. They're together. So now I know that 2 by 1, 2, 3, 4, 5, 6. 2 and 6 are factors of 12. Now let's try 3. So here we have 1, 2, 3, and then we can have 1, 2, 3, 1, 2, 3, and 1, 2, 3. So now I know I have 1, 2, 3 by 1, 2, 3, 4, and we don't have any oddballs. Now we have 1, 2, and 3. Let's try 4. So here we have 4, and then 4, and 4. And there's 1, 2, 3, 4 by 1, 2, 3. And I want to show you how 5 doesn't work. So here we have 4, and then 5. 1, 2, 3, 4, 5. And see how we have these two little oddballs? It doesn't make a pretty rectangle or square or anything to that effect. So that's why 5 is not a factor of 12. And I always tell my students, do you see how this repeats 3 times 4 and 4 times 3? I know that anything above where it repeats, those are all of the factors that I can have of 12. But let's just show the 6 by 2. So now we have 5. And now we can put these little ones down here. And we have 1, 2, 3, 4, 5, 6. And then 1, 2. So it would be 6 by 2. And then I can model the 12 by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then by 1. So there is the concrete, the manipulatives, how you can factor 12. I just started with the 12 unit blocks and then made pretty little models without any oddballs sticking out. So now let's look at the concrete. And we can do the same thing by modeling and drawing the little unit cubes here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here I have a 1 by 12. And then we can show 2 by there's 2, there's 2, 4, 6, 8, 10, 12. So now I see that it is a 2 by 1, 2, 3, 4, 5, 6. So I know that, let's just put that up there too. 1 and 12, 2 and 6. So let's try 3. So I can start by drawing the 3 boxes. So 3, 6, 9, 12. So that would be 3 by 1, 2, 3, 4. We can start with the 4. We have 1, 2, 3, 4 boxes, and we're just going to draw 4 boxes continually until we can get to 12 or past 12. Because if we go past 12, then we know that it's not a factor, it's too many. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 boxes. So I know on the side here I have 1, 2, 3, 4. 1, 2, 3. So 4 and 3 are factors. I want to show that 5 again. So if I start with 5 boxes, 1, 2, 3, 4, 5. Continue to draw 5 boxes. 1, 2, 3, 4, 5. So now I have 1, 2, 3, 4, 5 6, 7, 8, 9, 10. And then if I draw another row of 5, then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Since that next row made us have 15, then these are not factors of 5, because this would be a 5 by 5, and it does not work. I'm going to show the 6. So I have 1, 2, 3, 4, 5, 6 blocks. I'm going to draw another column of 6. So now let's count how many blocks we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that did make the 12. So I know it 1, 2, 3, 4, 5, 6 by 2. 6 and 2 are factors. And then we can have one column of 12. No, those aren't even and pretty, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 on the side, 1 going across, so I know 12 and 1 are factors. Now let's look at the factor rainbow. How I start off is I start with 1 and 12, because 1 will always be a factor of any number and then itself. So I can say 1 times 12 gives me 12. Then I go to 2. Does 2 work? Yes, it is divisible by 2. So 2, and you separate it by commas. 2 times what? Which would be 6. 2 times 6. And then 3 times 4. And since we got to 4, we're counting 1, 2, 3, 4. The next number would be 5. And since we have a little rainbow here, we can't go 1, 2, 3, 5. So that's why we start repeating. And then these are all of the factors of 12. So 1, 2, 3, 4, 6, and 12. Now my favorite, the T-chart. And the reason I call it a T-chart is I just put the number that we are factoring on the top, and then I draw a little T-chart, and I say always start with 1 and 12, because I know 1 times the number, those are factors, so 1 and 12. And then I can say 2 times what, and that would be 6, so 2 and 6. Then I go to the next number, 3. 3 times what? 4, and see how we are repeating here? We would go to 4 next, and 4 is already listed. I tell my students to draw a line, because that means I know I'm done. I've started to repeat, and that's all of the factors. This just looks a little neater to me compared to the rainbow. It's whatever strategy you like to use. So here is our map of how we modeled finding the factors, and also looking at little strategies that we can use as well. So now let's start looking at some examples. What are the factors of 24? I'm going to use a T-chart just because it is my favorite strategy to use. It's just neater. So 24, always start with 1. 1 times what? 24. Then I go to 2. Is this number divisible by 2? Since it is even, yes, it is divisible by 2. So then, if you have a hard time with your multiplication tables and you can't think of it, you can come to the side and say 24 divided by 2. And then you can use that standard algorithm of 2 divided by 2, or 2 divided by 2 is 1. 1 times 2 is 2. Subtract. Check. It's okay to have 0. Bring down the 4. 2 can go into 4 2 times. 2 times 2 is 4, subtract, and I do get 0. So I know that 2 times 12 gives you 24. So that means 2 and 12 are factors. Then I can think of 3. The divisibility rule for 3 is you add the numbers. So 2 plus 4 is 6. Is 6 a multiple of 3? Yes. So I know that 3 is a factor of 24. 3 times what? If you knew your multiplication tables, you know that 3 times 8 is 24. Then I go to 4. Is 4 a factor of 24? Since it is even, and then you look at the 2, and you can look over to the 12. Since the 12 is even as well, then I know that 4 can go into 24. It is a factor. So 4 times what? And I always tell my kids it rhymes. So 6 times 4 equals 24. Then I go to 5. The only numbers that 5 can go into has to end in a 0 or a 5. In this case, it doesn't. So 5 is not a factor. Then I go to 6. 6 is a factor. So, and we already have it, so we're repeating. So I know I'm finished. And I always like to come to the side and rewrite all of my answers. So I know that 1, 2, 3, 4, 6, 8, 12, and 24 are our factors. What is the GCF of 36 and 48? So we're going to look at both factors of these numbers. We're going to find the greatest common factor. Let's start with 36 and the T-chart. 1 and 36. We always start with 1. Can 2? Yes. 2, and then if you have a hard time finding the 2, you can come to the side. 2 can go into 3 one time, multiply, subtract, bring down. 2 times what gives you 16? 2 times 8. 8 times 2 is 16. Subtract, and I get 0. So I know that 2 times 18 gives you 36. Can 3? Yes. 3 times 12. And then 4, yes. 4 times 9. Can 5? No. Can 6? Yes. 6 times 6. It rhymes. In this case, we did repeat, so we are finished with the 36. Now let's look at 48. I always start with 1. 1 and 48. 2, because it is even, so I know that 2 can go into it. And 2 times 24. Can 3? Let's add the numbers. 8 plus 4 is 12, so yes, 3 can go into it. Let's go off to the side and let's divide it. One time, subtract, bring down, and then 3 into 18 is 6. 6 times 3 is 18. Subtract, and you get 0. So 3 times 16. Can 4? Yes, 4 and 12. 5 can't. 6 times 8, it rhymes. 7 can't. And then we get back to 8, and we already have 8 listed, so we are finished. Now we need to find the greatest common factor of these two numbers. I always tell my students to start on the larger side because you do want the greatest factor that they have in common. So they don't have 36. Do they both have 24? No. Do they both have 16? No. Do they both have 12? Yes. And so I tell them to circle it because they both have 6 in common. They both have 4, 3, and 2, and 1. But you want the greatest common factor. That's the G in GCF. So that what is the GCF of 36 and 48? 12. What is the GCF of 12 and 21? Let's start with 12 and our T-chart. We know that 1 and 12. Can 2? Yes, it is even. 2 times what? 2 times 6. Can 3? Yes, because 2 plus 1 is 3. 3 times what number? Well, 3 times 4. And then we get to 4. We already have it listed, so I know I'm finished. And the only reason I know how to do this so quickly is because I know my multiplication tables. I tell my students all the time, it is so important to know your multiplication tables. 21. Let's list the factors of 21. Always start with 1 and the number. Can 2? Well, it's not even, so no. 3? Yes, because 2 plus 1. 3 times what? 7. Can 4? No. Can 5? No. Can 6? No. And then we get back to 7, and we are finished because we are repeating. Starting on this side, we're going to find the greatest common factor. Do they both have 21 in common? No. Do they both have 7 in common? No. So since we are finished with this greatest side, we can come over to the other side and say 3. Do they have a 3 in common? Yes. Even though it's smaller and even though it is on the left, it still is the greatest common factor that they have in common. Sometimes the greatest common factor will be 1, and that's okay. That's okay if that's the only thing they have in common. What is the GCF of 12 and 21? 3. Write the following expression as a product of its GCF and another sum. So we have 25 plus 45. Let's start to find the factors. And we're going to find the greatest common factor that they have. Start with 1 and 25. Can 2? No. Can 3? Well, 5 plus 2 is 7, so no. Can 4? No. Can 5? Yes. 5 times 5. And since we repeated, we are finished. 45. 1 and 45. Can 2? No, it's not even. Can 3? 5 plus 4 is 9, so yes. 3. And 3 times 14. Can 4? No, it's not even. Can 5? Yes. 5 times 9. Can 6? No. Can 7? No. Can 8? No. Can 9? Yes, and we already have it listed. Let's go down the greater side first. Do they have 45 in common? No. 14? No. 9? No. Come to the other side, 5. Yes, and I always tell my students to circle those greatest common factors because of examples like this. So we want to find the product of its GCF and another sum, also known as factoring, and we want to write it as a distributive property. So that means I'm going to have to put 5 on the outside since 5 is what they have in common. And then in my parentheses, to find the numbers that's going to go in the parentheses, this is why I love this T-chart method, because I just look to the side and what number goes with my GCF is the number that goes into my parentheses. So I have the GCF of 5. 5 times what gives you 25? 5 times 5. I bring my addition sign. 5 times 9 gives you 45. So now we have factored out this problem, and I want to show you how that works. 25 plus 45, that's 70. 9 plus 5 is 14. And then when you don't have a sign between a number and parentheses, it does mean multiplication. And let's just come to the side and multiply 14 times 5, which is 20. 5 times 1 is 5, plus 2 is 70. So it does equal 70. They both equal 70, so that means these two expressions are equivalent. And let's look at our last example. Write the following expression as a product of its GCF and another sum. We have 36 and 54. Let's start with 36. 1 and 36. 2 can because it is even. Let's come to the side and divide. 2 can go into 3 one time. 1 times 2. Subtract and bring down. 2 times 8 is 16. Subtract. So 2 times 18. 3 and 12. 4 and 9. And then 6 and 6. And we are repeating. So let's do 54. 1 and 54. 2, and let's just divide it out. 2 times 2 is 4. Subtract, bring down. 2 into 14 is 7. 7 times 2 is 14. Subtract, and I get 0. 2 times 27, can 3? Yes, 5 plus 4. 3. 5 plus 4 is 9, and then 3 is a multiple, or 9 is a multiple of 3. Let's divide it out. Can go in one time, subtract, bring down. 8 times 3 is 24, subtract, so 18. Can 4? No. Can 5? No. Can 6? Yes. 6 times 9. Can 7? No. Can 8? No. And then we get back to 9. We already have it listed, so I know I'm finished. Now let's find our greatest common factor. Do they have 54 in common? No. 27? No. 18? Yes. I'm going to circle my 18. I'm going to put 18 on the outside of my parentheses. Since 36 is first, I always put the other factor that goes with 18 first. So, or goes with 36 first, which is 2, and then plus, and then I look on the other side of the 18 for 54, and that is 3. So 18 times 2 is 36. 18 times 3 is 54. Thank you for watching my video. I hope that you learned something new, a new strategy, or gained a better understanding of factors and finding factors in GCF, and also factoring addition expressions. I hope that I helped you, and if you like this video, give it a thumbs up. Add in the comments which strategy you like the most. I hope you enjoyed it, and click that red subscribe button so that you can watch more Math Mondays. Bye, y'all.